Let us review quiz 2, which will be done tomorrow. This is a review of quiz 2. So the two questions. Let's start by evaluating the integral of t squared exponential power 4t dt. So in this review of this quiz 2, we'll be working with integration by parts. I'll show two ways of doing this one, and you can choose the one that you prefer for the quiz. So integration by parts, which comes from product rule, but you are doing antiderivative. So the integral of u v prime or dv equals the integral of u prime v with a minus, I'll rearrange it later, plus uv. So in the book it's written, the integral of u dv equals to uv minus integral of v du. The choice of u requires you to remember this choice of u of x, the function of either u of x or any u, requires you to remember this acronym, which means logarithmic functions or natural log, inverse trig functions, algebraic functions, trigonometric function, or exponential functions. Or you can use this one, for you to choose u. So the one which comes first in this acronym should be your u. So in this case, our u of x, or u of t for this matter, is equals to t squared, because that's algebraic, which comes before exponential. And dv, or v prime, equals exponential power 4t. So if you find u prime, or derivative of u, is equals to 2t, and to find v, you integrate, and the integral, it's exponential power 4t the way it was. Now, instead of multiplying by 4, you multiply by the reciprocal of the derivative of the power. That's 1 over 4. So rearranging this, you get that the integral of t squared exponential power 4t with respect to t is equals to u, which is t squared, multiplied by v, which is 1 over 4 exponential power 4t. Then you minus the integral of v du. And the v is now 1 over 4 exponential power 4t. And the du, or u prime, it's times 2t dt. Now, to clean this up, you have t squared divided by 4 exponential to the power of 4t minus. These are number 2 there, so you can factor it out of the integral sign, and then 1 over 4, so you get 2 over 4. Then you integrate exponential to the power of 4t, then it's multiplied by t, so you can put a t in front with respect to t. So this still becomes t squared, to simplify, over 4 exponential to the power of 4t minus a half integral of t exponential to the power of 4t with respect to t. So let's now do this integral here, and we'll be careful with the factor 1 over 2 outside. So let's continue for this part. And again, we will call u as t, and we call dv as exponential to the power of 4t. Derivative of u, that's du, will be equals to dt, or 1 times dt, and the integral of dv, which is equals to v, is the one that we got before. That is 1 over 4 exponential to the power of 4t. So if we continue here, we have t squared divided by 4 exponential power 4t, the first part, this part, minus a half. And now recall the formula for integration by parts. We start by u, that's t, multiply by v, that's multiplying by 1 over 4 exponential to the power of 4t minus the integral of v du. And the v is 1 over 4 exponential to the power of 4t, and the du is dt. So we have done that. So again, we clean it up. We have t squared divided by 4 exponential to the power of 4t minus a half. This a half and this a quarter, it's 1 over 8 t exponential power 4t. This minus sign here and this minus sign here becomes plus. Then a half, this a half we find here, and a quarter there becomes 1 over 8. Then integral of exponential to the power of 4t with respect to t. So now we have, I keep on saying the equal sign because we need to follow up the steps. Exponential power 4t minus 1 over 8 t exponential power 4t. Now the integral here will plus 1 over 8. Again, we integrate. So we have exponential power 4t as usual. Then we multiply by 1 over the reciprocal of the power of that. Then we add a constant c because it's indefinite integral. So cleaning this one, we get t squared over 4 exponential power 4t minus 1 over 8 t exponential power 4t plus 1 over 8 times 1 over 4 is 1 over 32 exponential power 4t, then plus a constant c. And that's the integral of the one that we were given, integral of t squared exponential power 4t. So to just confirm this one, you can draw a chart as I showed you. And this side is the side for the signs, plus or minus the side for the signs. This is u, and this is dv. Let me call it v prime. Always remember that the chart we use if you're having two functions, one is algebra and exponential function, or algebra and trig functions. You cannot use it in any other two combinations other than those two either algebra and exponential, algebra and trig. So in this case, the first sign for the original function is plus, and it's the u, it's t squared, and the v prime or dv is exponential to the power of 4t. So the sign keeps on alternating. So we have a minus, and this one derivative, keep on finding the derivative of u to get u prime. That's 2t, and this one becomes the integral 1 over 4 exponential power 4t. Derivative, the sign here becomes plus, the derivative becomes 2, and this one becomes 1 over 16 exponential power 4t. The sign becomes negative, the derivative becomes 0, the integral here becomes 1 over 64 exponential power 4t. So you stop there when u becomes a 0. And then the answer for the integral, the one given here in the first row, exponential power 4t dt multiplied by t squared is equals to, this is the first answer, follow my arrow, t squared multiplied by 1 over 4, so it's 1 over 4 t squared exponential power 4t, and you can see that's the first part, t squared over 4 exponential power 4t. Follow the arrow, the second arrow goes to this one, that becomes with a minus sign, this minus, 2t over 16 exponential power 4t. Then the other one, for the sign, it's plus, so it's a plus sign. And you follow the arrow, you get 2 and 1 over 64. Plus 2 over 64 exponential power 4t. Then plus a constant c. Then you simplify. So this one becomes 1 over 4t squared, or t squared over 4 exponential power 4t minus 2 over 16, that's 1 over 8. So that is t over 8. Exponential power 4t plus 2 over 64, that's 1 over 32. Exponential power 4t plus a constant c. So you use the table if you're having two functions multiplied, one trig, one exponential, or one trig, one algebraic, one exponential, one algebraic. So you're having an algebraic with an exponential, algebraic with a trigonometry. It's safer to, you can cross-check using that table formation. Now let's do the second one. And this one is using fundamental theorem of calculus. So we have the limits of integration, 2 as the lower limit, 4 as the upper limit. And we have 3x multiplied by natural log of x power over 2 with respect to x. So don't use the table here because you're having algebraic and natural logarithm. So using our acronym LIATE, our u of x will be equals to natural log of x divided by 2. And our dv will be equals to 3x. So let's go ahead and find du, or u prime, which is equals to the derivative of ln of x over 2. If you can remember this one, when you are finding the elasticity of demand, we find that the derivative here, you first find the derivative of the inner part, that is derivative of x over 2, that is 1 over 2. You divide by the original function. So divide by the original function, which is inside the ln, that's x over 2. Or you can use the chain rule, and you get that this is a half times 2 over x, which is 1 over x. Now, the integral of this, you get a v is equals to 3 over 2x squared, because you add 1 to the power divided by the new power. Now, the rule uv prime is equals to uv, or minus integral of vu prime, or v du. And we have the limits as 2, 4, upper and lower limit, 2, 4, upper and lower limit, and then here we solve 2, 4 after we find u and v. Now let's substitute them in our formula. So the integral from 2 to 4, this implies integral from 2 to 4 of 3x natural log of x over 2 with respect to x is equals to u, and our u, it's ln of x over 2. Let me write ln x over 2 v. And our v, it's 3 over 2x squared. Let me write it in front here. 3 over 2x squared multiplied by ln. Then you are solving this one from limits of integration 2 to 4 and 2 minus the vu prime. So minus the integral from 2 to 4 v, which is 3 over 2. So I can factor out 3 over 2 x squared du, and du is 1 over x. So you're multiplying by 1, so by 1 over x, 1 over x with respect to x. Simply becomes 3 over 2x squared ln of x over 2. I'll put the limits of integration later, minus 3 over 2. Then the integral for this one, you can cancel, simplify x. X will cancel with another x, you get x. So you're integrating from 2 to 4, x with respect to x. Let me put 2 to 4 here as the limits of integration. So we will get 3 over 2x squared ln of x over 2 minus 3 over 2. The integral of x is x squared over 2. So you are getting multiplied by x squared over 2. And then everything here will be now the limits of integration from 2 to 4 for all of them. So now here, that's when you use the fundamental theorem of calculus, which is f of upper limit, f of 4, minus the function antiderivative at 2. So let's start by substituting at 4. So the first part, we have 3 over 2. Instead of x, you put 4. So you square 4. ln 4 divided by 2, that's 2. Minus 3 over 2 multiplied by 4 squared. We can write 16 divided by 2. So this one becomes 3 over 2 times 16. That's 3 over 8, which is 24. ln of 2 minus, this is 4 and this is 16. So 3 times 16 over 4, that's 12. Let's find f at 2. So substituting 2 in this function. So you have 3 over 2. Where you have x, you put 2. So square 2. Then ln of 2 divided by 2, that's 1, minus 3 over 2 multiplied by x is 2. So you're squaring 2. Then you're dividing by 2. So which becomes, don't forget that ln of 1 is equals to 0. So that part becomes a 0. So you're having a 0 minus. So you're having a minus 3 times 4 divided by 4. That's minus 3. And then fundamental theorem of calculus, which is like this, the integral from 2 to 4 of the function which was given f of x dx is equals to f at 4 minus f at 2. So you subtract f of 4 minus f at 2, which is just 24 ln of 2 minus 12, then minus with another minus. So minus minus, you get a plus. So the answer results to 24 ln of 2 minus 9. That's the end of the view quiz for tomorrow.